Hello.
Hello.
Hey, how's it going?
Good. How are you doing?
Pretty good. I guess just came into my room.
Okay, no problem. So, would you like to introduce yourself?
Sure. So I guess for context, I'm a CS student studying for coding interviews for new grad roles right now. I did a couple of previous internships at some, I guess, larger companies. Um, yeah, I guess for the anonymous part, I'd have to just leave it at that, right?
Yeah, it's up to your discretion. You can just leave it there. And,
Sure.
so let's get started. So you're given a non-empty array of integers and a number k. Return the uh, k most frequent elements. So
Uh,
you can return a list of integers which are the top k frequent which are recurring at least k number of times.
okay, so I didn't fully understand that
Okay,
question.
let
I heard a
okay
few.
let me explain. Given a non-empty array of integers, return the k most frequent element. So I'll
Yeah.
give you an example. So say for example, here is yeah. So
Okay.
input array is 3 ones, 2 twos, and 1 3, and k is 2. So one does recur at least twice, right? It's more than twice. One is 3 times, two is 2 times, three is just once.
Okay.
So in the output, you're supposed to return a list of integers. What's your preferred language? Is it Python or Java? Python,
Yeah,
right?
use Python. Okay, so got it. That makes a lot more sense to me. I thought there was also the condition that the number had to occur at least k times. I thought you mentioned that at the end, but that's not a requirement. So it could
No.
also be, like, um, okay, I can't think of an example, but right, you mentioned it's just no, it doesn't have to happen that many times. Cool. So going through some ideas for what you'd want for this. It seems like right off the bat, a naive approach you could take is that you can actually put you could iterate through the numbers, uh,
Okay.
and then just add to some count the number
Mm-hmm.
of times that each of the numbers showed up,
Okay.
convert the final map that you have into a list form, and then sort the resulting list. So you end up taking n time to iterate through to count,
Okay.
n time to convert map to an array, and then you take n log n time to convert, where n is of course the length of the input array,
Mm-hmm.
uh, and then you should be able to just get the final k items right out of your sorted list. So that's a naive approach, and I think we definitely should be able to improve on that.
Okay.
This one on its own is n log n runtime complexity, which comes from just the sort.
Mm-hmm.
Uh, so instead, we should be able to do something that takes, I would guess, n log k time instead. So how would we do that? The k most frequent elements, what we could end up storing as we iterate through is maybe a number as well as its count. So let's
Mm-hmm.
say I'm thinking initially that I would want to use a heap for this somehow, but it's not really clear how that strings together, right? So basically, with the k most frequent elements, I could say store the frequencies at which numbers occur.
Mm-hmm.
Uh, inside the values for each of the nodes, store what the actual nodes are, right? But how would I go on and construct that heap? Let's say what I could start off with is I keep on filling in my heap with
Mm-hmm.
the relevant counts
Okay.
and the values as I iterate through, but there's no way for me to the problem with using that is that there's no way for me to uh, you know um, remove or update an item in the middle of the heap, right? Yeah, that's the main problem with that because my counts
Like
are updating as I iterate
how,
through.
how about using a priority queue? Oh, I'm not sure if Python has a priority queue. So in priority queue, if you look at in Java, probably you can have a separate class which is just representing the number and the number of occurrences.
Okay.
And then within the priority queue, you can insert new elements. And the new element would always be like a class, and that structure would have the number and its number of occurrences. If you do that, you would end up only having the top, as long as the priority queue size is less than k, you keep adding elements, otherwise you don't.
Yeah, right. So that ends up being similar, right, as what we'd want with the heap, because I'm pretty sure for a lot of priority queues, they use binary heaps underneath, right?
Yes.
Yeah, so this is similar. I think the solution to what I was saying before with there's no way for me to know how to update in the middle is if I go through the first time and actually construct this new data set, which
Mm-hmm.
says that I'm going to associate each of the numbers with their count, then I should be able to go through that new map structure, and for the first k items, just insert into the heap, and then past that, I should be able to what's it called? Uh, remove values based on the frequency, right? So k most frequent elements means that when I iterate through, I want to have a min heap, and then I want to say that the value that is at the root of my min heap is actually going to be the smallest of the k, like the k less frequent, right? The k
Yes.
least frequent, which means that as I iterate through, if the value that I have is greater than the root, then it means it is one of the k most frequent. So I can pop from the heap and then push in the new item. And this ends up being the n log k runtime complexity that I wanted from earlier. Just because I'm going to go through all of the items n times, but I'm going to end up taking, sorry, I should update that. I don't take n log k. I end up taking n time to make my intermediate data, and then I take c log k runtime complexity, where c is the number of unique characters. Does that make, yeah, I guess that makes sense, right? Like, I have the,
So you are still iterating through the entire given array, right?
yeah,
So the order computational complexity will be order n plus order c log k, right?
yeah. So I guess, yeah, that's what I was trying to get at when I was saying that putting the n on top. So this is that plus this. I guess it depends on which one is larger, and I want to say that it's pretty much the max between these, right? It
Mm-hmm.
depends on the specific set of data that you get. So if it turns out that all of the items are say unique, then C
Mm-hmm.
log k is going to be larger, right? But if it turns out that there's lots of distinct, sorry, yeah, if they're all unique, then C log k is larger, versus if it turns out that there's a lot of overlap, then it may be that n is larger, right?
Can you explain? Because you will not know until you iterate the entire array if all of them are unique or not.
Yeah, so let's say we have our example of 1, 2, 3, 4, 5, 6, or 6 elements. Here, n is
Okay?
equal to 6, right? But
Yes.
we have 3 times the other value for C is 3, and this is times log 2. And I'm pretty sure that 3 times log 2 is less than 6, right?
So then order of complexity is still 6, right? Order n, right?
Yeah. but let's say that they're all unique. 1, 2, 3, 4, 5, 6. Now suddenly C log 6 is greater than 6, right?
And C is what?
Actually not true at all. Yeah, this is log base 2, so 6 is, you know, log 2 of 6 is greater than 1, right? So that means that 6 times log base 2 of 6 is greater than 6. So that's what I'm saying. So in this case, C equals 6.
Okay. So 6 times log 6 base 2. Not really sure how much the value would be. Let me just check. Let me check how much would log 2.
I mean, log 2 of 6 has to be, it's
0.
definitely
7.
greater, right? It's
It's 0.7,
0.7.
right?
Wait, what?
0.777.
Is that in log 2 or log 10?
Maybe it's log 10. Hold on.
Okay.
2.5, 2.58.
Right. Right. So
2.58 times 6.
right. So like I guess like that's the point that I was trying to get at, that it's the max between them, right?
Yeah.
If we were to give, you know, a tight bound on this, but really you can think of it as being linear, but this is just like a tighter bound. Okay, so given this, is it okay if I code it out?
Yeah, go ahead. So which one do you think is more, which one are you going to code up? The first one or second one?
I'm going to go with the second solution using the heap, right?
Okay, go ahead.
This is the naive approach, and from line 18 you have the improved approach, right? Cool. So from Q, import heap by, I think it's heap push pop. I guess we'll see. And then we have our class is going to be a single node. Self, comma.
I have a quick question. Even in your first approach, why would it be n log n? Because you iterate through the entire array first, and then you populate the hash map, and then you're just taking the key set and then just sorting that. So the sorting for just the unique elements, which are
I see what you're saying. It ends up being C log C here, right? So again, it ends up being the max of, yeah, it ends up being the max between the n and C log C.
you know what, maybe you're right. It will be n log n because when you take, oh no, my bad. So the number of keys will still be unique. So it will be C log C. You're right. C log C would be the runtime complexity, and it will always be so. But in your second approach, it's going to vary, right?
Yeah.
So which one do you think is better?
I mean, the other one is definitely a lot simpler to, you know, calculate, right? But I'm going to say that, well, I mean, it varies for both of them. So it's the exact same test case. Like if you have 1, 2, 3, 4, 5, 6, then that ends up being, you know, C log C time, right? But if you have 1, 1, 1, 2, 2, 3, then that gives you n time as the, the longest it's going to take. Or sorry, I think I have those backwards. I would still want to, I guess, go with the heap because, like, to me that makes more sense than just the naive approach, right?
Okay, go ahead.
Sure. Value, and I'll need to implement a less than operator, I think. So other turn self.count is less than other.count. I think this is how it ends up working if I want to use my own custom class, but I'm not entirely sure, and we can check. So, right, the actual bigger function is I want to find the k most frequent inside of some array. So edge cases is if, I mean, it's supposed to be non-empty, but let's say that isn't. In that case, we just return the empty array. And now what we have is we want to go through and create our counts map, right? Which, let's say this is a default dict from collections or default dict. And for some context, basically what a default dict allows me to do is say that instead of using a normal hash map, I have a hash map or dictionary form where if I do a key lookup for some value and it's of a type integer, then by default it's going to return 0. So that when I try to say do let's say my count of a is plus equal to 1, and that key never existed, I'm not going to get a key error. Instead, the count is going to be set to 1. It's just like a convenience, object. So cool. Moving on, I have my default dict of counts, and what I want to say is that for item inside the array, counts of item is going to plus equals 1. So now I just avoid all of those checks for keys and all that. And finally, I have my result. And what I want to do is go through each of the items inside of counts. And for the first k of them, I'm going to just pop them in, and afterwards I'm going to add items that are relevant. So one thing I didn't get clarified as a constraint is, am I going to be guaranteed that there are at least k unique items?
Yes.
Okay, so in that case, I don't need to do any edge case check here. All I have to do is for value comma count in counts.items, I want to say that if this is supposed to be a heap, right?
Yes.
Yeah, so I actually need to update this. I guess I also need heap push. So if len of result is less than k, then all I have to do is heap push, say node is equal to a node with count in this specific value. All I need to do is push onto the heap is my result, the current node. Cool. And then I continue and go to the next item. So if my len of result is not less than k, this is the point where I need to actually push pop the new node that I found onto my heap. So all I should have to do is heap push pop my result, the existing node. Cool.
Okay.
Yeah, so hopefully the less than operator is correct, and if it is, then we should end up having after the heap push pop steps the okay, I mixed this up. I was supposed to say that I only sometimes heap push pop, right? It's supposed to be that if the current count is greater than my root node, in that case, I want to heap push pop. Because all that's saying is that this current count is greater than the k, the k largest we have existing, right? Yeah, and then in the end, all we want to do is mutate the result array. So instead of actually having a result as a bunch of objects, you want to have the node dot value for node in result, just because we pushed all those objects earlier. So running this with an actual test case, let's go with what you had, where we set nums is equal to the following array, then k is equal to 2. We want to print k most frequent on nums and k. There may be an error here. Int object has no attribute count. How did that end up happening? Int object has no attribute count. So each time self is supposed to just be a node, right? Is this
I'm not familiar with Python at all. I work with Java, so I can't help you in this one. You are free to look up online if you want.
Sure. Let me say heap custom object Python. Oh no, do I have to create a custom heap? Okay, this does seem to be exactly what I want to do. That does not help. Okay, so somewhere I'm inserting inside of my result array. Okay, that's why it's failing. So it's supposed to be if node is greater than result. So the comparison is failing not for the heap portion, but because I was actually comparing the int directly.
Okay.
Cool. So we have 2 and 3, which means that this is backwards, the less than. And I think the other way around, it should give us 2 and 1, which is what we wanted. Let's go with some more test cases. Let's do the empty array with 1. And you want to have the completely empty array, which should give you hopefully 0. Cool. I think this is a pretty good enough set of test cases, so I'm going to go ahead and say that that's my solution.
Sure. So good job. I think that is all I have for you. I can write my feedback in interview IO. So do you have any more questions for me?